A galaxy is a giant system composed of stars, planets, gas, dust, dark matter, and other astronomical objects bound together by gravity. These cosmic structures can contain from a few million to trillions of stars and span hundreds of thousands of light years. Galaxies come in many shapes and sizes. The main types are spiral galaxies, such as the Milky Way, are disc-shaped with pronounced arms in which stars are actively forming. Elliptical galaxies are elongated, oval structures containing mostly old stars and little gas. Irregular galaxies have no distinct shape and are often the result of gravitational interaction with other galaxies. Galaxies formed in the distant past when clouds of gas and dust began to accumulate in space. Under the action of gravity, these clouds compacted to form the first stars and star clusters. Over time, these clusters coalesced to form larger structures, proto-galaxies, that later evolved into modern galaxies. The main components of galaxies. Stars are the basic building material of galaxies. They can exist as single objects, double systems, or as part of star clusters. Interstellar gas and dust are the raw materials for the formation of new stars. In spiral galaxies, gas clouds are especially active in star formation sites. Dark matter is an invisible substance that makes up to 85% of a galaxy's mass. Although its nature remains a mystery, its presence is confirmed by its gravitational influence on visible matter. Black holes are particularly supermassive, located at the centers of most galaxies. They play a key role in their evolution. What causes a galaxy to rotate about its axis? Galaxies rotate due to the conservation of angular momentum they acquired in the early stages of formation. When clouds of gas and dust were compressed by gravity, they began to rotate faster, similar to the way a figure skater speeds up his rotation by pressing his arms against his body. However, scientists noticed that the outer regions of galaxies rotate at almost the same speed as their central regions, which contradicts the laws of classical mechanics. This phenomenon is explained by the presence of dark matter, which creates additional gravity and keeps stars from flying apart. Some galaxies have satellites, smaller galaxies orbiting around them. For example, the Milky Way has several satellites, including the large and small Magellanic Clouds. These are held together by gravity and may eventually merge with the main galaxy. In addition to dwarf galaxies, satellites can be globular star clusters, dense groups of old stars orbiting the galaxy. Gas clouds, massive clouds of hydrogen from which new stars can be born. Isolated stars, sometimes individual stars, can be ejected from galaxies, remaining on their periphery. Almost every large galaxy contains in its center a supermassive black hole, whose mass can reach millions and even billions of solar masses. Scientists believe that these objects began to form in the early universe due to the collapse of massive stars and the subsequent merger of smaller black holes. The role of supermassive black holes in galactic life. Regulation of star formation. By absorbing surrounding gas, black holes can slow down or, conversely, stimulate the formation of new stars. Gravitational influence. Black holes influence the motion of stars in the central regions of the galaxy. Formation of active galactic nuclei. Some black holes actively absorb matter, creating powerful energy emissions that can be observed in the form of quasars and active galactic nuclei. Future collision between the Milky Way and Andromeda. The Andromeda Galaxy, the Milky Way's nearest large neighbor, is moving towards us at a speed of about 110 kilometers per second. According to astronomers' calculations, in 4.5 billion years, both galaxies will collide. This process will last millions of years, but it will not lead to catastrophic destruction of stellar systems. as the distances between stars are too great. In the course of the merger, galaxies will begin to deform due to gravitational interaction. Bursts of star formation will lead to the birth of many new stars. Eventually, the Milky Way and Andromeda will merge into one giant elliptical galaxy, which scientists call the Mlecomeda. Despite the enormity of this event, our solar system will probably remain intact, but the night sky will change forever, filled with new stars and nebulae.